Hi everyone, it's Coach Fred here, and today I'm going to be going over questions 14 and 15, I think. So this is on the trig test, but it's a review question, and it deals with logs, specifically the natural log. Remember that natural log, ln, is just another way to write log of base e. And we talked, you should have learned this year a little bit about the irrational number e. Okay, so it says find the exact solutions. When you're dealing with a log equation, okay, you need to understand that to solve a log equation, you have to use the inverse operation. The inverse operation is an exponential function. However, you want your equation simplified on both sides. So this is where you have to use your log properties to simplify each side of the equation. One tip I always give students is there's two goals you want before you actually use exponential functions or equations to solve or use the inverse operation. You want to have a log equals a log, so a single log equals a single log, or a log equals a number. Once you hit those two things, you can either use exponents or you can use a property that allows you to cancel the logs. All right, so let me show you what I mean. So 3 ln x minus ln 2. So I have to simplify each expression on the left and the right before I can do anything. All right, well, I have to work backwards. The property tells me that 3 can come up to the top. So ln x cubed minus ln 2. Now remember, the property we talked about in the earlier video was that if you had log a over b, you could write that as log a minus b. That would be if you were expanding it, but you also have to be able to go backwards to condense it. So now I'm set up to write this as ln x cubed over 2. All right. On the other side, I have to simplify, and I see addition. So remember we said that if we had log a times b, we could write that as log a plus log b. The base doesn't really matter. And ln is a log, so ln is the same thing. So I have this, I need to work backwards, so it's telling me to take these two arguments and multiply them. So that would give me ln x squared plus 12x. All right, well this is nice because I've got now log equals log. So just like if I had 2 to the x equaled 2 to the 5, the one-to-one property basically says the structure here allows me to cancel the 2's. Well, the structure here, the one-to-one property, tells me that I can cancel the logs. So that would give me x cubed over 2 equals x squared plus 12x. All right, well, I have an equation with fractions, so it's Coach Fred here. If you've seen anything I do, I hate fractions in my equations, so I'm going to clear them by multiplying the whole thing by the lowest common denominator of 2. All right, so that's going to give me x cubed equals 2x squared plus 24x. Okay, so I see a polynomial equation. I'm going to isolate it, get it set equal to 0. So x cubed minus 2x squared plus 24x equals 0. Goodness gracious, now I've got a factor, right? I see a common factor of x. I'm going to pull out the x, giving me x squared minus 2x plus 24. So that factor is a quadratic, and I can actually factor it more. Is that x minus 6, x plus 4? All right, so I have 3 solutions. I have x equals 0 using the 0 product property. Oops, I don't want yellow. I'm switch to purple. X equals 0, x equals 6, and x equals negative 4. But hopefully you remember that the log function has a domain restriction. So the graph of the log, let me just draw it real quick. The graph of the log looks like this. And there's an asymptote at x equals 0. So that means that values, the argument here, and here, it always has to be greater than 0. It can't be negative and it can't be 0. There's no way for that output to come out of the function. So that means that these two answers are extraneous. Oops. got too excited there. So these are extraneous. And so my answer would have to be x equals 6. Okay, so your answer to this equation would have been x equals 6. All right, moving on to number 15. Graph using the 5-step process. So I will tell you, this takes some time and practice, right? It really does, and you have to know all of the different pieces. And I encourage you to watch the supplemental videos to practice this, to go through it. And if you need help, let's practice together. Let me know. All right, so first you want to find your amplitude. Now remember amplitude, these are in the form y equals a sine bx x minus c plus d. So before I do anything, I really want to rewrite it in that form. So you can see the b needs to get pulled outside of those parentheses. So I'm going to rewrite it by factoring out the b. Okay, all right, so now my amplitude. Amplitude is the absolute value of my a term. It's half the distance between the max and the min, so my amplitude is 2. My period, I have to find my new period. We know the period of pi is 2 pi, so we do 2 pi over b. So 2 pi over 4, so pi over 2. That means that one full cycle of the graph is going to happen. If it starts at 0, it's going to happen by pi over 2. Okay, so now I get my quarter period. This is that part that I do. So a quarter of pi over 2 would give me pi over 8. Right, I just multiply by 1/4. Okay, my phase shift is my right or left. My left or right shift, it comes from here. So this would be going left pi over 4. I like to think of that as my new starting point of one cycle. And then my vertical shift, this is my d term, so it's going down 1. Okay. Now remember, my domain of this function will always be negative infinity to infinity, because I can put any x value in, right? It's going to go all along the x's. It's the range that's going to change, so we're going to wait to see what the graph looks like. Okay, I'm going to give us some room here. Okay. All right, so I'm going to actually make my graph. And I'm going to just do one cycle, but we could do more than that. What does it ask us to do? Yeah, it doesn't say, so I'm just going to do one cycle, okay? All right, so let me get back to where we were. Sorry, my computer's being iffy today. Okay. All right, so the first thing I'm going to do is my vertical shift, because it's moving down 1, so my midline is actually moving down 1 unit. Okay, so my midline from 0, it's normally at 0, is going to go down to 1. Negative 1. So I'm going to put in a dotted line for my midline. Okay, I've used my vertical shift. Then from there, I'm going to do my amplitude. So I'm going to go up 2 units, so that would put me at 1, and I'm going to go down 2 units, which would put me at negative 3. Let me make this a little bit more in scale. That's not even right. Maybe like right there and right there. So I'm at negative 3. So I know that 1's going to be the highest, negative 3 is going to be the lowest of my graph. So that actually tells me my range, but we're going to stop there. Okay, so then we are going to make our phase shift and our quarter periods have the same denominator. So that's going to give me a phase shift then of 2 pi over 8. Okay, I know it's pi over 4 though, but all my increments are going to be pi over 8s. Okay, so here I am. I'm going to go left to 2 pi over 8. So there's going to be pi over 8. So there's going to be 2 pi over 8. So I'm going to go, actually we're going to do 2 cycles. So I'm going to go pi over 8, and then to 0, and then to another pi over 8, and then to another pi over, so that would be 1 pi over 8, 2 pi over 8, 3 pi over 8, right? We've gone. We're going to go another pi over 8, so that would be 2 pi over 8, which would be pi over 4. And then another pi over 8 would be 3 pi over 8. And then 4 pi over 8 would be pi over 2. And then 5 pi over 8. And then 6 pi over 8 would be 3 pi over 4. And then 7 pi over 8. I think that's enough. Did I do that right? I hope so. Okay, so sine starts at the midline. So I'm going to start at negative 2 pi over 8. Okay, so I'm going to start here at the midline. Sine goes up, except, was our graph negative? Our graph was negative, so instead of going up, I actually have to go down. So then I'm going to go down to negative pi over 3, back at 0, up at pi over 8, down at pi over 4, down here, back up to the midline, back up, and back down. That looks like it's 2 rotations, so let's see. And there's 2 periods of the graph. Okay, so how can I just check to make sure I've done all this right? Well, number one, you should be able to verbally describe what's happening here. So we have an amplitude of 2. So from the midline, am I going up 2 and down 2? I certainly am. But one way I always like to check myself is actually to look at a table of values or check Desmos. So I've already done that. I put the graph into Desmos here. And so I put in my graph. And then I plugged in my points, my x values that I came up with along the x-axis. And you can see it's starting negative pi over 4 to negative 1, gives me a y value of negative 1. Negative pi over 8 was at negative 3, 0, negative 1. So you can see those values. There's, that negative 2 pi over 8, which was pi over 4, which was at negative 1, then down to negative 3, then up to negative 1, and then back up to 1. So there's lots of ways that you can check your answers on this one. Again, that 5-step process really just breaks it down into parts, okay? Hopefully that was helpful. Have a great day.